My name is Yogendra Kumar. I'm a maths teacher at askIITians. Okay, today we are going to do probability chapter, which comes in your final exam for almost 4 marks, right? Okay, it is having weightage, board weightage as 4 marks, right? So this is a really important chapter. Okay, you can easily expect one long answer and one short answer question. Okay, like that it could be there, right? So let's start. It is pretty simple chapter, right? I hope you can score full in the final exam, right? So let's understand this. You'll find it much easier. Okay, so what are the topics we are going to cover today? We are going to see what is experimental versus theoretical probability, right? What is the difference between the two? Then we are going to see definition of probability, outcomes, and sample space, and what is an event, right? So let's get started. So what is theoretical probability? Okay, if you say like I like some prediction or some like something like they want to forecast, okay, like that, like weather department, okay, they want to forecast that tomorrow it might be rainy day, right? Tomorrow it might be raining. So they see the previous record, what happened previously, previous years, in this month, in this year, okay, this day, okay, what happens previously, right? They forecast on the basis of that, or like we have the data available, on that basis we are telling this is what happening, right? So you can understand, like with the example, I think this will be clear, that experimental is what, like what happened, and then on that basis we are defining, like a coin is tossed 10 times, head is recorded 7 times, and tail is recorded 3 times, right? So what is the probability of getting head when we are throwing the coin, right? So it is 7 by 10. And what is the probability of tail? It is 3 by 10, right? Simple. So it is based on the experiment already happened, already previous data we have, and we are on that basis we are calling it, right? We are forecasting it, right? Now what is theoretical? According to mathematics, what is going to happen right now, right? What is, if I toss a coin, okay, either I'm going to get head or tail, right? Fair coin it is. So that is what 50% chances are there. But so there are two things, right? Theoretically this should happen, experimentally based, okay, like this happened, right? So this is what it is. Exactly right. Okay, this is what we need to understand. This is what the basic difference between experimental probability and theoretical probability. By the way, definition of the probability is what? Number of favorable outcomes divided by total number of possible outcomes. So like head is one only, so one divided by two possible total outcomes are what? Okay, head or tail. If I need to write down the sample space for a coin, right? So what is the sample space we will give for this? Sample space will be having head or tail, right? These are the two events. Now we want to see head, right? So event is what? Getting head. So that is having one element only. So probability of E is what? 1 divided by 2, means number of elements in the favorable outcomes divided by number of elements in this divided by total number of outcomes. Okay, so that is 2, right? This is what it is. So you can see the definition also. Theoretical probability is what we expect to happen, where experimental probability is what actually happens when we try it out, right? So this is what it is, right? Actually what is happening and what happened, what expected to happen. So that is what the difference, right? Slight different, okay, difference, okay, that is what you need to observe. As more trials are conducted, the experimental probability generally gets closer to the theoretical probability, right? Okay, obviously when we perform, because it is expected, this happened, okay, 7 times head came, it's fine, right? But what is supposed to happen? 1 by 2 should be it, ideally, right? What is the probability? We say when I throw a coin, what is the probability? 1 by 2 it should be, right? 50% chances. But it shows it is not 50%, it is deviating from this thing, okay, theoretical thing, right? It's fine, but when you perform it more, it is like more closer to that, right? So this is what we say. So now this simple question: a bag contains 10 red marbles, 8 blue marbles, and 2 yellow marbles, right? You can see the in the picture. Find the experimental probability of getting a blue marble. Experimental probability of getting a blue marble. So blue marbles are what? Okay, here we don't have any previous data, right? So probability is what? Going to be how many blue marbles are there? 8 blue marbles. Okay, like here it is not the exact number. You need to see the data here. 8 divided by what are the total? 20, right? So we can say 4 twos are divided by 4 fives are 2 divided by 5, right? We don't have any previous data or like that. Okay, what happened there? Okay, so theoretical is what here, experimental. We need to give the same answer, right? Okay. Okay, now what is happening here? Okay, what are they providing? Okay, bag contains 10 red, 8 blue, and 2 yellow marbles. Find the experimental probability of getting a blue marble. Yes, that's correct. 8 by 20, right? Because total marbles are what? Total number of marbles. Marbles are what? We have 10 plus 8 plus 2, which is what? 20, right? And how many blue marbles are there? 8. So 8 by 20. Take a marble from the bag, record the color, return the marble, repeat a few times. Okay. Okay, I think this is not the proper experimental of the getting blue marble from the bag is 6 by 10. No. I think they didn't take it properly. Okay, it's fine, right? You need to remember this is what we have, right? This is what we need to remember. Now find the probability of rolling an even number when you roll a die containing the number, right? Okay, one moment. Okay, like coming back to previous question, if suppose we have the record, okay, we have the data like with us, when we picked out the like marbles, okay, we got some data. If we have like first attempt we got this blue marble, we got blue marble like that, okay, we have the data, then we will predict. I'll take the similar example, but okay, let's go further to the next question. Okay, find the probability of rolling an even number when you roll a die containing the numbers 1 to 6. Express the probability as a fraction, decimal ratio, and percent, right? Express the probability as a fraction, decimal ratio, and percentage, right? So we want to find out the even number. So how many even numbers are there? E is what? Okay, E is the probability. Okay, E is the event, right? So what it is? 2, 4, and 6. Now what is sample space we have? 1, 2, 3, 4, 5, and 6, right? This is what we have. So probability of E will be what? N of E divided by N of S. That is the definition of probability, right? Number of events, number of elements in the event divided by number of elements in the sample space. So this is 3 divided by 6, which is 1 by 2. Now, if they want it as a fraction, we got it. Okay, decimal 0.5, ratio obviously 1 by 2, right? Ratio, then percentage. Okay, so 50%, because 1 by 2 into 100, it'll be what? 50%, right? 50% probability, right? Like this we will give the answer. I hope you got it, right? This is what we do. Okay, now definition of probability, a branch of maths with that deals with the likelihood of the occurrence of a given event, right? So it is just a simple definition, favorable outcomes divided by total possible outcomes. This is what we need to remember, right? Okay, now there is a container full of colored bottles, red, blue, green, and oranges. Okay, some of the bottles are picked up out of and displaced. Okay, Sumit did this 1,000 times and got. Okay, this is what actually we have the experimental probability we have here, because it is what based on the previous data we are going to talk about. So similar thing should be there in the previous question also, but that was not given, so that's why we need to understand it this way. What is the probability that Sumit will pick up a green bottle? So now he picked up blue bottles, he picked up 300,000 times he did, and he found that he picked up green bottles. So 450 divided by 1,000, right? That should be our answer. So 45 by 100, and this is what? 5 nines are 5, 2, 9 by 20. Simple, right? Because green bottles came 450 times. So if he is picking the green bottle, right, that is like 450 compared to all other right here, right? This is what it is total. Okay, now if there are 100 bottles in the container, how many of them are likely to be green, right? If there are 100 bottles, okay, so 45 are likely to be, okay, 45 because 4,000 if you compare, okay, like I think you can get it by comparison, right? If we have 450 times we are picking up what green bottle, right? So what we have, okay, if 100 bottles are there, the ratio will reduce, okay, 30 will be blue, okay, 20 will be red, and 5 will be oranges, right? Like that we will do. I hope you got it. Yes, this is what the answer we got. Now, what is outcome and sample space? Outcome is what simple point, okay, we call it all like one of the element from that full sample space. Outcome is what? If I'm throwing a dice, so getting 6, that is one of the outcome, right? Full sample space is what? Sample space is what? 1, 2, 3, 4, 5, 6. This is what our full sample space. Now, what is outcome? If I'm getting any number like 2, that is what? One of the outcome. If I'm getting 4, that is one of the outcome, right? Like that we have. This is what we have. These are the outcomes. So full set is what? Sample space. An event is a subset of sample space. Subset means one of the element, right? By the way, you're going to do next year a chapter which is what sets, and that you are going to learn this all in detail. But as of now, you can have briefly, okay, this notation. S is a sample set, okay, one in which we have all the possible outcomes. So outcome is what? These all listed possibilities, right? Listed possibilities. So sample point, right? 2, 3, like that. Full thing is what? Sample space, and one of the outcome is what? Sample point. Right. So this is what it is. If I throw 2 dice, let's say sample space for 2 dice. So what will be the sample space for 2 dice? 1, 1, 1, 2, like that. 1, 6, then 2, 1, 2, 2, and 2, 6. Then like this, we will have 6, 1, 6, 2, and 6, 6. Right, like this. So this is what full sample space we have. 36 outcomes will be there. N is what? Number of elements in the sample space. That will be 36, right? Here what is it? N of S is what? 6. So construct a sample space for the experiment that contains rolling of a single die. Fine. Okay, rolling of a sample space for this. I have already shown you. 1, 2, 3, 4, 5, and 6. Find the event that corresponds to the phrases. An even number is rolled. Find the events that, okay, so event E will be having like 2, even number is rolled 2, 4, 6, and a number greater than 2 is rolled. Okay, so they are saying even number and greater than 2. So we need to remove from here. We will have to remove here 2 because that is not greater than 2. So let's remove this. So this is what our sample space, right? We can understand. Okay, I think they wanted separately. Okay, fine. You can do it like 2 ways. Okay, when they are saying okay 2 here, and if this is what separately, if together they want, then we need to remove here only 2. E2, let's say even 3 now greater than 3 2. So 2, 3, 4, 5, and 6, like this. This is what another event we have. Right, I hope you got it. So what is an event? In theory, probability theory, an event is an outcome or defined a collection of outcomes. 2 events could be there, right? This is what it is. Event is any subset of a sample space, right? Yes, I hope you got it right. Any single outcome is what? An event, or it could be 2 or more outcomes also. Now, what is it? Independent events and dependent events. Okay, this is, I think you don't get much questions right now, but it is what important here. Independent events are what? When They do not depend on each other, right? The events are not bothering the occurrence of each other. That is what independent events. Dependent events, then when they are affecting each other, right? I hope you got it. Okay, like what I'm saying now here. Uh, if example, if I need to take from a deck of 52 cards, I'm picking up a king, and that is supposed to be a king. A probability of picking up a king. Okay, so that will be what? Probability of picking up a king is what? 1 by 52. Now in the second draw, I want to draw one more card. And now first card, I didn't replace here, that one, right? I have that card with me, and I'm picking out another card, right? So this will be like 4 by, sorry, my bad. Okay, 4 by 52 it will be, picking up a card, first card. Now second draw, P of E2. Second time also I want another king. So that will be 3 by 50, not 52, because how many cards are left? How many cards are left now? 51. So we need to write here 51. So you can see it is affected, right? This is what, when E1 happened, that time we are doing. Now, if I say I replace the card back, I picked up a card and I want the probability for that to be king. Now I'm replacing that card back. Card is replaced. Okay, it is replaced back in the deck. So now probability of E2 picking up another king will be what? 4 by 52 itself. It is same, right? It's not affected. So that is what this second one is, what? Independent case. This is dependent. If we don't write here E2 by E1, okay, that is also fine. Like the way they showed it, right? So that is also okay, but we need to remember that it is depending on the previous case, right? This is what dependent and independent case. Okay. Now in a game of snakes and ladders, okay, a fair die is thrown. Event E1 represents all the events of getting a natural number less than 4. Event E2 consists of all the numbers of getting an even number, and E2 denotes all the events of getting an odd number. List these sets representation of the following. Okay, now they're telling E1 or E2 or E3, right? Sets representation they want. Okay, so E1 is what represents all the events of getting natural numbers less than 4. So natural numbers less than 4 will be what? Now, or you need to understand as union. Okay, so if one of the set natural number less than 4 will be what? 1, 2, 3. Now union, event E2 consists of all the events of getting an even number. So 2, 4, 6. Union, or is what you need to consider as union, right? E3 denotes all the events of getting an odd number. So 1, 3, and 5. So we need to take the union of all these. So I think we are getting 1. 1 is there. This or this or this. So 1, 2, 3, 4, 5, and 6. We are getting full sample space. So this is what our final thing here. Now they're telling E1 and E2 and E3. So that contains what? Intersection of all these. Okay. This will contain intersection of all these sets. So what is common in all? 3, no. 1, no. 1 is not available here. 2, is 2 available in all? 2 is available here, but it is not available in third one. Is 3 available in all? No. So nothing. So 5. We'll say none. All right. You can say none. Nothing is there, right? 5 set. Okay. I think we should not try represent it this way. It is like empty set. You can leave it like this, or 5 set. Nothing is common. Now they're telling E1 but not E3, E2. E1 but not E3. Okay, by the way, this representation is what? Uh, 1, 2, 3, 2, 4, 6, 1, 3, 5, like this. Okay, now what are they're saying? E1, which is what? 1, 2, 3, but not E3. So intersection, not E3 means what? Okay, it is what? Not E3 is what? Like E1 intersection E3 prime. E3 prime is what? Even numbers here. 2, 4, 6. Right. Apart from the full set, U minus A. E3 dash is what? U minus E3. Means apart from 1, 2, 3, all other numbers. So which are what? We have even numbers only left out. So that's why, what is it here? Which is 2 only. Right. This is what we got. Right. I hope you're understanding. Right. You can see all these cases. Right. This is how we do it. Right. Okay. We can do all these questions now for our practice. Okay, a bag contains 10 red marbles, 8 blue marbles, and 2 yellow. Find the theoretical probability of getting blue marbles. So 8 by 20, which is what? 2 by 5. Construct a sample space of experiment consisting of tossing a single coin. So what it will be? Head and tail. Okay. Draw a random card from a pack of cards. What is the probability that card drawn is a face card? Face cards are how many? There are 12 face cards divided by 52, right? This is what you need to remember, that 12 face cards are there. So 3 by 13. That should be our answer, right? 2 by 5 H and T and 3 by 13, right? These are the answers we have. You need to practice a little bit more to understand it clearly, right? Okay, thank you very much for joining this session. Okay, let's continue to the next session. Okay, next class. Thank you. Bye bye.